This is the second experimental lab in Physics 2212, and in this lab our main objective is to find the amount of excess charge in common household items such as tape, make simplifying assumptions to make the calculation process easier. Um, we apply Newton's second law and electric field equations just like lab 1, but the biggest difference between lab 1 and lab 2 is that this time we applied the line charge model to better represent the charges in the tape instead of just using a single point charge to represent the tapes. Now we're going to talk about the physics concepts needed in this lab. It's very similar to lab 1 where Coulomb's law is very useful to find force between two point charges located at a distance r away. And the second concept is very fundamental. It's the equation of gravity acting on an object on Earth. And Newton's second law states that the net force acting on an object is the rate of change of its momentum. And since we know that an object in equilibrium has zero change in momentum, therefore no force acting on it. And we're going to use this because the net force acting on a floating U-tape is zero because it's stationary, it's not moving. Moving on. We started the experiment by creating a charged U-tape by pulling it apart from the base U-tape. We bring it close to a negatively charged planar comb to test what charge the U-tape has. We observe whether they repel or attract. In our case, they attract, therefore we can conclude that the page is positively charged. And then we move on to create two charged U-tapes, put them on top of each other in a way that the top one floats. And then we find the distance between the two tapes and just note it down. So the collected data is on the screen. Length of tape, mass of tape, and distance between the floating tape B and A. Moving on to calculations, we start out by finding the gravitational force on tape B. Then by drawing a free body diagram on tape B, we find out the electric force and the gravitational forces are opposite. Since the tape is floating, therefore stationary in the y direction, the net force acting on the tape on the y direction is zero according to Newton's second law. Therefore, we set the magnitudes equal to each other and then continue solving. Note, by the way, in our cases, in our assumptions, we said that both charges needed to be equal on A and B. Therefore, we can just calculate one and we'll get the other. So the biggest difference between lab 1 and lab 2 is the fact that we model the tapes as line charges in this lab instead of point charges, and we make some key assumptions along the way. For starters, each Q-tape has the same amount of charge just like lab 1. This time we treat each U-tape has uniform distribution of charge instead of point charge, and that is the biggest difference between lab 1 and lab 2. And in my case, I basically treated the tape as a triangular prism and divided it into 20 chunks and used GlowScript. And we basically treated the tape charges as a whole, not caring about the internal interaction between the charges, because that would make it way more complicated. And we ignore air resistance as usual. So I omitted the code because of simplicity reasons, and it was too big to fit. Basically, you can see here that in lab 1, like you had just a single point charge and electric field acting on top of it and gravity acting on the opposite side. But in this case, you can see a lot of point charges instead of just one. It's because of the line model that we're using on this lab. So the difference between treating it as a point charge and line charge, for the answer, we actually end up getting very different answers because as we can see that point charge model actually underestimated the amount of charge that would be on the tape. So what if I had modeled each tape like a single point charge? So the forces would be needed to cancel out for the tape to be floating, which doesn't happen when we use an old Q value from lab 1 because that would not be accurate. So the estimates do differ, and basically the reason is lab 1 tries to simplify the problem by treating it as a point charge, while in lab 2 we improve our implementation just a bit by how the charges are getting distributed in a line model. And charge 2 should be more accurate because a line charge is closer to the representation of the actual shape of what a piece of tape looks like. And also another reason is charges are in chunks, like charges that are in chunks experience interaction from all the other chunks. So basically a point charge on one tape would experience interaction from all the point charges on the other tape, and that definitely throws away our calculations in the first lab and gives us something new. That's it for this week. Thank you.